Hello everyone. Today this section presents problem based on Gauss divergence theorem. Verify Gauss divergence theorem for f vector equal to f vector equal to 4x z I vector minus y square j vector plus y z k vector over the cube bounded by x equal to 0, x equal to 1 and y equal to 0, y equal to 1 and z equal to 0, z equal to 1. So over the cube bounded by, so first here we going to draw the cube. This is the cube and this is the origin, and this is x-axis, y-axis, z-axis. In x-axis the direction is I vector. In y-axis the direction is j vector. In z-axis the direction is k vector. And opposite to the x-axis is this is minus I vector. And opposite to the y-axis is minus j vector. The direction is minus j vector. And opposite to the z-axis, the direction is minus k vector. So here, this one is face A, B, C, D. And this one is E, F, G, H. So in the cube, there is 6 faces. There is face A, B, C, D, E, F, G, H, and the side face is right side face D, C, G, H, and the left side face A, B, F, E, and the upper face A, D, H, E, and the lower face B, C, G, F. So according to the Gauss divergence theorem is given by triple integral of V divergence of f vector dv equal to double integral of s f vector dot n vector ds. So here f vector equal to, here f vector equal to 4x z I vector minus y square j vector plus y z k. Therefore, divergence of f vector equal to, we know divergence means I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z dot f vector equal to 4x z I vector minus y square j vector plus y z k vector. So you know I vector dot I vector equal to 1, but I vector dot j vector equal to 0, I vector dot k vector equal to 0. J vector dot I vector equal to 0, but j vector dot j vector equal to 1. Similarly, k vector dot k vector equal to 1, k vector dot I vector j vector equal to 0. So therefore, finally this equation will become divergence of f vector equal to I vector dot I vector equal to 1. Therefore, dou by dou x of 4xz plus dou by dou y of minus y square plus dou by dou z of yz. So therefore divergence of f vector equal to the differentiation of x equal to 1 and other terms are constant. Therefore 4xz equal to, with respect partial differential with respect to x equal to 4z, and this minus dou y square by y, differentiation of y square with respect to y equal to 2y, and differentiation of z with respect to z equal to 1, therefore plus y. and the triple integral divergence of f vector dv equal to triple integral divergence of f vector equal to 4z minus 2y plus y equal to minus y, and dv is nothing but dx dy dz. So therefore here integral limits of dx, that is in the x-axis, the limits is x equal to 0 to x equal to 1. So x in x-axis the limits is x equal to 0 to x equal to 1. So therefore the limits will become 0 to 1 for x-axis and 0 to 1 for y and 0 to 1 for z. So therefore here we go to integral 0 to 1 4z minus y dx. You will here we go to integral first this one. So therefore 0 to 1 0 to 1 integral of with respect to x. Therefore 4z x minus y is x. Limits is 0 to 1 dy dz. Here we go to apply the upper limit minus lower limit. Obviously this term will become, there is no change, that is 0 to 1 4z minus y, and here integral with respect to dy dz. So here the next step, here we go to integral 0 to 1 4z minus y with respect to y. So therefore 0 to 1 integral of 4z with respect to y equal to 4zy, integral of y equal to y square by 2 with limit 0 to 1 dz. So here we go to apply the upper limit, that is 0 to 1 equal to 4z minus 1 by 2 with respect to dz. So upper limit 1 and lower limit 0, therefore upper limit minus lower limit. So therefore minus lower limit equal to 0. So therefore the final term will become 4z minus 1 by 2. And finally here we go to integral this term with respect to z. So therefore 4z square by 2 minus z by 2. Limit 0 to 1. Therefore once here we go to apply the upper limit, therefore 4 by 2 minus 1 by 2. Therefore this term will become, that is nothing but 4 minus 1 by 2, that is 3 by 2. So that is triple integral of v divergence of f vector, dv equal to. So this equation will become equation 1, or this one as per the formula. This is in the left hand side. So obviously this one is the left hand side of Gauss divergence theorem. Okay. And next one, okay. And next one here we consider, I want to rub this side. So I want this diagram for one tabular column. So here I want to rub the question, because already you know what actual question is. So therefore I want a diagram. So here next one, double integral of s f vector dot n vector ds equal to double integral of s1 plus double integral of s2 plus double integral of s3 plus double integral of s4 plus double integral of s5 plus double integral of s6. So this one will become equation number 2. And next here I go to put one tabular column. So in the tabular column, here I go to mention phases, equation, n vector, ds, limits. If you understand this tabular column means this problem is nothing, very simple. So So first, I already told you in the cube there is a 6 faces. So A, B, C, D is one face. So A, B, C, D face A, B, C, D, and this one is considered as face S1. Here the equation, this is in z-axis. So here z equal to 1 because this is the origin. This is x equal to 0, y equal to 0, z equal to 0, and in the z-axis this point will become z equal to 1. So here face A, B, C, D, the equation z equal to 1. So this point z equal to 1. So therefore this is z equal to 1 and n vector. In the z-axis the direction is k vector. So this one is k vector and ds. So here this face ABCD in x-axis and y-axis. The face ABCD in x-axis and y-axis. Therefore ds equal to dx into dy. And the limits is nothing but that is the x limit 0 to 1 and y limit is nothing but 0 to 1 according to the question, according to the cube with limits. And similarly next phase EFGH. This is phase S2 and in this phase is in the z-axis with z equal to 0. So therefore equation z equal to 0 and that is the opposite to the z-axis. Therefore the direction for n vector equal to minus k vector. And similarly this phase also in x-axis and y-axis. Therefore this will become ds equal to dx dy and limits is nothing but x equal to 0 to 1 and y equal to 0 to 1. Okay, and now we come to the next phase, that is the right hand side phase. The right hand side phase, the phase is DCGH. This is phase S3. Here x6 in this point, this phase in x equal to 1. So therefore x equal to 1 and in the x-axis the direction is I vector. So n vector equal to I vector and ds. So this phase in y-axis and z-axis. So therefore ds equal to dy dz and limits is nothing but y equal to 0 to 1 and z equal to 0 to 1. And next phase ABFE, that is phase S4. This is in the origin, therefore x equal to 0, that is opposite. And next one, opposite to the x-axis, therefore the direction is minus I vector. And phase ABFE in y-axis and z-axis, therefore ds equal to dy dz. And there is no doubt y limits equal to 0 to 1 and its limits z limits equal to 0 to 1. And there is a two phase remaining. And next phase, upper phase ADHE equal to S5. And here y equal to 1. The equation, this phase in this upper phase in y equal to 1. So therefore y equal to 1 and in y-axis the direction is j vector. Therefore this one is j vector. And here ds, that is the surface area in z-axis and x-axis. Therefore dx dz. So therefore here limits x equal to 0 to 1 and z limits is 0 to 1. And next one, bottom face BCGF S6. In the bottom face here y equal to 0, that is in the origin, and opposite to the y-axis, therefore n vector equal to minus j vector, and this also in z-axis and x-axis surface area. Therefore ds equal to dx dz. Therefore there is no doubt x equal to limit 0 to 1 z equal to 0 to 1. Okay, so here I describe the cube in detailed form, and here I describe this cube in detailed form. So from next step onwards, we don't need this cube. We refer the table and fill. Here we go to find double integral of S1. That is nothing but double integral. By using these values, here we go to find the double integral of S1. So from next step onwards, we don't need this cube. Here I detailly describe this cube in this tabular column. Okay. So next one, here we go to find first double integral of S1. Double integral of S1 equal to double integral of f vector dot n vector ds equal to double integral of S1 face f vector dot n vector. You know f vector. F vector equal to, tell me, f vector equal to x square. F vector equal to 4x z I vector minus y square k vector plus
y square j vector.
Y square,
y square j vector plus
y square j vector plus
y z k vector.
y z k vector. And for S1, ds equal to n vector equal to k vector. Therefore, dot k vector and ds equal to dx dy. So x limit equal to 0 to 1, y limit equal to 0 to 1. Here z equal to 1. Therefore, I already told you that is k vector dot I vector equal to k vector dot j vector equal to 0. But k vector dot k vector equal to 1. So therefore, this term will become 0 to 1, 0 to 1. K vector dot I vector, k vector dot j vector equal to 0. Therefore, k vector dot k vector equal to 1. Therefore, the final equation will become yz dx dy. And here, equation z equal to 1. So, therefore, 0 to 1, 0 to 1, y dx dy. So, first here you go to integral this one. You will get 0 to 1, y x 0 to 1 dy. Therefore, that is nothing but 0 to 1 y dy. And therefore, here we go to integral of y equal to y square by 2. Therefore, y square by 2, 0 to 1. Therefore, the final term, double integral of S1 equal to 1 by 2. And next one, here we go to find double integral of S1. Okay, I want to rub this side because I want to this tabular column for up to here we go to find S1, S2, S3, S4, S5, S6. So I want to rub only the one side. The next side, double integral of S2 f vector dot n vector ds equal to, that is nothing but double integral of f vector equal to 4x z I vector minus y square j vector plus y z k vector, right?
Yes.
Right? Y z k vector, right? So therefore, n vector equal to minus k vector and dx dy. So here x limits is 0 to 1, y limits is 0 to 1. And here minus term, therefore minus double integral of 0 to 1, 0 to 1, k vector dot I vector, k vector dot j vector equal to 0, but k vector dot k vector equal to 1. Therefore, final term will become y z dx dy. But in the equation for phase 2, z equal to 0. So therefore, double integral of S2 f vector dot n vector ds equal to 0. And next, double integral of S3. Double integral of f vector dot n vector ds equal to double integral of 4x z I vector minus y square j vector plus y z k vector, right? S3 I vector dot I vector n vector equal to I vector and dy dz. So therefore this is equal to y limits is 0 to 1, z limits is 0 to 1, and I vector dot I vector equal to 1, I vector dot j vector, I vector dot k vector equal to 0. So therefore 0 to 1, 0 to 1, 4x z dy dz. First here we go to integral, the first one, therefore 0 to 1, 4x y, limits is 0 to 1 dz, y upper limit equal to 1, therefore this term will become 0 to 1, 4x y, that is 1 minus lower limit 0, therefore 1 into 4x equal to 4x dz. But in the equation x equal to 1, so therefore here we consider only 4z. Okay. So therefore here we got integral with respect to z, therefore 4z square by 2, 0 to 1. So therefore here 2, 4 cancel 2 and upper limit equal to 1, therefore this answer will become 2. That is the double integral of S3 equal to 2. And next one, double integral of S4. S4 equal to double integral of f vector dot n vector ds equal to double integral of 4x I vector minus y square j vector plus y z k vector. And here the phase S4 n vector equal to minus I vector, therefore minus I vector ds equal to dy dz. So therefore, and the limits of y equal to 0 to 1, limits of z equal to 0 to 1. So therefore 0 to 1 I vector minus dot I vector dot minus I vector, so therefore put minus here, that is very important, and I vector dot I vector equal to 1, therefore remaining term is 4x dy dz. But the equation for phase S4 x equal to 0. So therefore double integral of S4 equal to 0. And next one, phase S5. Double integral of S5 equal to double integral of f vector dot n vector ds equal to double integral of 4x I vector minus y square j vector plus y k vector dot for S5 j vector and dx dz for ds. So here limits of x equal to 0 to 1, limits of z equal to 0 to 1. So I vector dot j vector dot I vector, j vector dot k vector equal to 0. But j vector dot j vector equal to 1. So therefore the final term will become minus y square dx dz. But in this equation y equal to 1. Equation y equal to 1. Therefore, this will become 0 to 1, 0 to 1 minus 1 dx dz. So, integral of minus 1 with respect to x. Therefore, 0 to 1 minus x. So, put minus in the outside. That is easy for you. So, put minus outside. Therefore, x 0 to 1 dz. Therefore, that is nothing but 0 to 1 dz, put minus outside. And here again we go to integral with respect to z of 1. You will get minus 0 to 1. Therefore, the final answer will become minus 1. So therefore, double integral of S5 equal to minus 1. and the final steps will become. And the final step, double integral of S6 equal to double integral of f vector dot n vector ds equal to double integral of 4x I vector minus y square j vector plus y z k vector. N vector equal to minus j vector and ds equal to dx dz. X limit equal to 0 to 1, y limit, z limit is 0 to 1, and I vector dot j vector equal to 0, j vector dot k vector equal to 0, j vector dot minus j vector, put minus outside, 0 to 1, 0 to 1, j vector dot j vector equal to 1, therefore minus y square dx dz. But in the equation x6 space y equal to 0. So therefore equation y equal to 0. So therefore double integral of S6 equal to 0. So next here we go to proceed the last step. Double integral of S f vector dot n vector ds equal to, that is double integral of S1 equal to 1 by 2, double integral of S2 equal to 0, double integral of S2, S3 equal to 2, double integral of S4 equal to 0, double integral of S5 equal to minus 1, double integral of S6 equal to 0. Put in equation number 2. You will get 1 by 2 plus 0
Plus 1
plus 2 plus 0 minus 1. So therefore 1 by 2 plus 1, that is equal to 3 by 2. So double integral of S f vector dot n vector ds equal to, and this is RHS, and this is equation number 3, and this one is the RHS. So from equation 1 and 3, triple integral of V divergence f vector dv equal to double integral of S f vector dot n vector ds equal to 3 by 2. Hence Gauss divergence theorem verified. Thank you for watching. Thank you. I hope all are enjoy this section. Thank you very much.